designing them and being in a factory, just designing like you guys are designing your projects, I'm going to out to customers and help them use the parts that were designed by the team in the factory. The reason I did that is, and you two should be good at it, is that some engineers are good just doing something and just having their head down and they don't really want to talk to people. If you have talents, and the guy who runs the program, Dave, has the same talent, if you talk to people and make them understand things, you can be in a different job if you go into applications and not just be an engineer. So there's different things you can do, different things I've done during my career. I've been a guy in the factory, don't talk to customers, don't want to talk to customers, just design my chip, go home. Now I talk to customers. It's actually fun trying to help them solve their problems. So there's different things you can do, and you have to look at that once you become an engineer. Everybody's going to become an engineer? What kind? What kind? You have to speak.
Architectural.
Architectural. So buildings. You're going to have to talk to people with that one. Okay? Why would an architect have to talk to people?
You have to work with other people, like engineers. Well,
You have to talk to the person you're designing it for because it's not what you want, it's what they want. You put your own stuff into it. What kind of engineering?
You also have to explain like your design.
So the engineer who is the typical geek when I grew up was not somebody who talked to anybody, just was good in school and never did anything else. To me, that stereotypical geek is gone. That's not possible anymore because it affects so many other things. Back then, it was very different. You could have guys in their cube. Well, we still have guys in their cubes just doing their stuff. But it's no longer that because the things that I did at Intel affected 3 or 4 different things. Plus, what I do today, I have to interact with almost everybody in our company in different ways. So, does it work? Is there other things going on with it? How do we produce it? How do I spin it? Because sometimes it's not good. Okay? People make mistakes and we have to spin it as, you've all seen the thing that says it's not a bug and then it looks like a bug. It's a feature. Yep. I had to spin that. Okay, it actually was a bug. And we had to spin it as, no, it's used this way and it's better and here's your workaround. Here's your fix. So what kind of engineering would you want to do? Architectural again. Anybody in mechanical or what? To me, architecture more. It's funny. You're not in the engineering school when you take architecture. Do you realize that? It's weird. Okay. The one thing I do is some people I know have actually got a degree in civil engineering and become an architect after that because then they understand everything that goes on with building and structure, so they don't build something that will break. There's a giggle over here. Jason lived in a house that the roof broke in one of the storms because somebody designed it as a stick like this. And once the roof got there, the load bearing was only here, it peeled apart and did this and moved. So there were houses built, that was built in what, 1975, 76, they were built, couldn't stand the snow that would happen every 100 years in Colorado. So understanding some of the underlying items that you do might be helpful. For example, I designed computer chips, and I'm going to show you one. You guys can pass this around. Try to hold it by the sides. And why do I say that? Why would I?
ESD.
Yeah, you say ESD?
That's my guess.
Yeah. I don't want you to pop the board. This board's only $100. Only. Okay?
what is the difference?
I'll get to that. Okay? I'm going to do that.
That is not a Qdoba.
It says Qdoba on the bag.
It didn't have quesadillas, doesn't it?
I understand that. Okay.
Why don't we do like 10, 15 more minutes to talk, and then we'll break for lunch, then we'll have question and answer over lunch.
Okay. That board is the same as this board, only smaller. It's funny, I asked Jason, who's a pretty intelligent guy, what's the difference between the two boards? And he kind of looked at it and goes, that one's smaller. His nickname is Captain Obvious, feel free to use it. The difference between the board is that this is made as a development board for software. So this is the board I work on. So somebody can take the chip, I can pass this around too, I don't really care about it. The chip, if you see in the middle, is almost the same, if not the same. the plastic's on it, so when I travel with it, I don't break capacitors off of it. You guys can try to identify the capacitors that I might break off of it. It's on one side of the board. So what I do with that board is I actually program the chip, it's software, and there's a special part of it that is programmable hardware. A special thing that my company does. But I'm going to just go with the software piece of it. It has processors on it, and I program them to do certain things. Now, we were talking about this when I came in, that it can be programmed to, this is some of the fun stuff, that device can be programmed to be a missile. So it's actually used in defense systems and in missiles, and it's programmed, and what it does is that chip does the target acquisition and follows the target till it hits it. So it does that. The other thing that it does, and we were talking about it, it does what people call driver assist, software driver assist systems. And they're in cars. Dave, what kind of car do you have?
Oh, I just bought a minivan.
You bought a minivan. Any,
So cool.
so, well,
You know it.
you have to have it at certain times in your life.
That's right.
Does it have lane departure warning or any kind of object detection?
No, I don't like any of that stuff.
Okay.
This is
That,
so cool, dude.
that chip,
Distraction.
well, if you know how to drive, you don't need it. We won't go into that one. I just spun that marketing to make Dave
You just
look
said
like
you
a good
can.
driver.
No, he said I can.
You can.
He said if you don't need, if you have it, you don't need it.
As we
If you have the
talked
skill.
about in that chip actually is hooked up to anywhere between 2 and 6 cameras. Anybody doing stuff with cameras? Did you guys?
Nayeli is.
You are. So what you'll do is you'll take in a signal, that camera signal. What is that in? And no idea is fine. You can look at me and say, I don't know. I'm okay with that. That's the other thing, that when you're presenting and you're being confident about it, somebody asks you a question, I don't know is a perfectly good answer. The engineer who knows everything in my book doesn't. Pretends. So usually a video signal is taken in and it actually is captured by a camera and it's translated to a video type standard. Anybody work with a TV? Anybody put together a TV recently? You can answer, okay? Usually Jason's not allowed to answer my questions. So what kind of cables did you hook up? You plugged it into the wall?
Yeah.
You didn't? Okay, and they say Smoky Hill is better. I just had to go. You guys can
You got that on video, right?
Okay. So what cables do you hook up when you do video?
Oh, the white, yellow, and the red.
Yes, the white, the yellow, and the red.
He said 3 colors.
Actually, it's the yellow is the video signal, and the red and white are the 2-channel audio signals. Okay, that's an old side. We've now come to HDMI. There's RGB is other things. So when a camera takes it in, it transforms it into that kind of digital signal, and then it can be processed. So if I'm doing processing on a video signal, what might I want to process, given the 2 examples I just gave you? Missile or the car? Missile. What am I processing? If a camera's looking out there, what am I doing? What am I trying to process? Trying to find a target. It's funny, the automobile system is the same, only it's not a target, it's an object you want to avoid. So the missile takes it in and does, it's funny how they're similar in that aspect. The processing is similar. So you take in video, and the car is going to go, person, avoid, ball. Ooh, there may be a young person coming by it. I may want to slow down. You may look at a traffic sign and say, while I'm speeding, I want to slow down. Lane, the white lines, it's called lane departure. You can actually have a signal saying you're sliding over the lane. How many people's parents drift out of the lane? We'll talk. And I do drift. How many people don't text while they're driving? You guys don't drive that much. How many people's parents, how many people have seen a car drift and you know they're on their phone? I've seen that way too many times. What the software does is actually look at, there's multiple cameras, and it's taking this in and doing all this processing. This processing takes power at what computer science people or electrical engineers called power. And power is how much can I process in a given amount of time. Okay? You guys are processing me right now. Yeah, I actually had that happen. I caught a guy sleeping in one of the sessions. I just did some training and I noticed the guy in the back totally out. I called him on it too. That's the fun part. So it's power. And I'll give you an example of power. Jason, pull out your phone. You're the best example of that. He's got a phone. How much processing power do you think he has in that little thing? Power, huh? Give a number to it. 20. And I hold up this one. This is Samsung S6. Compare it to the two. 100. Now we go to a laptop. Could be. The order of magnitude is good between these. This is probably not an order of magnitude. So we do processing power, and it comes into what you're running on here. Most of you guys are running a microcontroller, right? And it has firmware on it. Are those flashes on the microcontrollers you're using so you can reflash it?
Yeah, you can absolutely reflash it.
Why I ask this is, we asked about firmware. Firmware is just software that's stored in a different media in my mind. So it's harder to change. Okay? On the board that you guys took around, my glasses are set up. There's a device that's a flash. And by a flash, I mean you can rewrite it, but it holds it. Okay? A USB stick. Everybody's, what do you guys call those? I call them USB sticks, thumb drives, what other names? USB. Those are firm. Firm flash drive. That's actually their NAND controllers in there, but that's a different story. So I'll just pull this one up. Everybody seen an SD card? Okay. Is it the same as a USB drive? A little. Why would you say a little? But what's the light between the two of them? They both store stuff. And if I take it out of the power supply, will it still be there? Okay. Your computer has another thing that won't. So firmware is usually stored in something that if you unplug it, it still is around. That's, to me, the difference between software and firmware. Software goes into memory that if you unplug it, it goes away. Just an idea. So you guys have microcontrollers that you're using in programming. Okay? I don't work. This device, which is the new one, and I'm not going to pass this board around because it's a $5 board, and there's not that many around, has a device in here. Okay? It's the device I work on. There is the earlier version that you guys can see in there. In that version, there is 2 microprocessors. So it's very similar to what's in your phone, not the kind that's in your computer. Okay?
We can plug in like our phones.
You could probably do that. It's not going to recognize it, but you could actually do that and it'll look as a storage device.
Is it a storage devices?
No, that actually will do a lot of programming on it. If you pick up the other board, that little board you have audio and video on, and people use that as a maker board to try to do different things. So if you guys are actually doing stuff that in the industry is called maker. So there's different boards you can use, and why I'm talking about processors is that that has 2 processors on it, very similar to what's on your phone. Very powerful, can do a lot of stuff, and I just mentioned a few things that it's in. This guy right here has 6 microprocessors and 6 microcontrollers. So your Arduino is 1 microcontroller. Okay? The laptop in here probably has 4 microprocessors on the high end. So I'm going into that a little bit to say there's a lot of stuff you guys can do with Raspberry Pi, with Arduino, and there are different levels of computing power. I work on what I call middle end. This is not the highest thing you can get out there. So we're in devices like, we're not in cell phones because we take too much voltage or too much power in a battery sense, not computing power. There's differences there. So we actually work in a lot of things in mid-range. And this is why I get to the cell phones. This and this are about the same, with this being a little bit more processing power and what I work on. Okay? The computer's a little bit more, but not much. when you get into servers, there are a little bit more there, so it's good to know about what you're programming. You guys are doing microcontrollers. They're the first thing that was out. They've been around forever, and they're great. They're in your life in so many different ways you can't even imagine. So, for example, how many people use a key to enter their car? Really? You don't use your fob?
No, I do it myself.
Nobody uses this?
No.
You use a key?
Yeah.
Wow. This has a microcontroller in it. Almost their entire life is microcontrollers, is where I'm going with it. So, I'm gonna go back to what I do. Right now, I'm working on this board. The device just came out about 6 months ago, and I try to teach people about how to use it. So my main job as a technical marketing engineer is to teach not only our customers, but our factory and our field on how to use it and how to sell it. So that's where I get to spinning. So there are some things in here that are not really good. I look at our guys and say, really doesn't work, but this is how to sell it or spin it. So I have two different things. What do I do mostly during my day? Do a lot of PowerPoint and a lot of conference calls and a lot of Excel spreadsheets. And then I get to do fun that I'm actually programming this guy trying to debug it. So on a day-to-day basis, that's what I do. I also have the nicety that I work out of my house. So that's one thing that people think should happen more, and I've watched it over the last 30 years to it happens sometimes, and it doesn't. And it doesn't seem to be any trend at this point in time. It just is the factory or where I would have a cubicle is in Longmont. That's 50 miles away from where I live. I really don't feel like driving through the middle of Denver, and I have a boss who is in California, so it's not like I'm going to see my boss every day. So I'm working from home. It really doesn't matter. Half our team is in Hyderabad, India, so I'm on phone calls late in the evening or early in the morning, so I make my own schedule. That's why I can be here in the middle of the day on short notice. We're done with the three? Okay.
All right, so let's break for lunch and have question and answer.